Good morning. Today we continue with integration techniques. So we don't have too many techniques to cover. I think by the end of the week we should be done with all the techniques that you need to know for the test. So remember that the test is next week Friday. I hope you're already preparing for that. More than likely it's just going to be on integration alone, right? Because this is quite a long chapter. So today we look at integrals. Of the form, this is the integral of the square root of a squared minus x squared dx. So with integrals that look like this, we have to make some trigonometric substitutions, because if this was in the denominator, then we would think of a sine or hyperbolic sign, but when it's in the numerator, we cannot use a sine or hyperbolic sign inverse. So with this one, we make a substitution, and the substitution that we make is this. So we let x equal to a sine theta, and then from there we can work out dx and then substitute it in there. Then we will see that what we have to integrate is actually much simpler than what we started with. So differentiating, we have dx, this is a cos theta d theta, and then just substitute it over there. We have the integral of the square root of a squared minus x squared. We square this, we get a squared sine squared theta, and then for dx we have a cos theta d theta, so times a cos theta d theta. Okay, we see that under our square root, a squared is a common factor, so we can factorize that out. This is the integral of the square root a squared 1 minus sine squared theta, and then on the outside we have a cos theta d theta. The square root of a squared is just a, so this a squared can come out of the square root, and then we have a times the a that is outside, and then we will have a, this is the integral of a, and then under our square root, 1 minus sine squared theta we know is cos squared theta, so the square root of cos squared theta, and then a cos theta d theta. Okay, the square root of cos squared theta is just cos theta, and then multiplying everything out, we have the integral of a squared cos squared theta d theta, and this we know how to integrate. So the a squared is a constant, so obviously it can go out, and then a cos squared theta we would then rewrite in terms of its double angle identity. So this is a squared, the integral, and then cos, we said this is half 1 plus cos 2 theta d theta. So this obviously very easy to integrate. The half would multiply out, and then we integrate. We have a squared. Then the integral of a half is just theta over 2. And then the integral of cos 2 theta is sine 2 theta divided by 2. So plus sine 2 theta divided by 2. Then we add our constant of integration. Then our a squared can multiply out. We have a squared theta over 2 plus a squared sine 2 theta over 2 plus c. Then we need to remember that the question that we started with was in terms of x. There was no theta. This was a substitution that we made. So we need to unsubstitute. And we know that sine 2 theta is 2 sine theta cos theta. So this is a squared theta over 2 plus a squared sine theta cos theta plus c. Now the substitution we made was x is equal to a sine theta. So this means that sine theta is equal to x over a. So we can draw a right angled triangle. We put theta over here, and we know that sine is the opposite over the hypotenuse. So this is the opposite, that is the hypotenuse, and this is a squared minus x squared. Okay, then we would work out sine theta from our triangle, and well, we have sine theta already. Cos theta is the one we use the triangle to get. So our integral is just a squared theta over 2 plus a squared. Sine theta here is x over a, so times x over a. And then cos theta, cos we know is the adjacent divided by the hypotenuse. So this is the square root of a squared minus x squared divided by a, and then our constant of integration. So in the denominator here, I have a times a, which is a squared, and it'll cancel with that one. So a squared, and with both of these, then when we write it nicely, what did I miss? A squared over 2. Is this right? Let me see. Okay, that's a half. Okay, yeah, I see. It was in the integration of this. This half must multiply like that. So this sign should be over 4 because of the half that was outside. So this is over 4, and then this is over 2, and then there should be a 2 here. Okay, so again, where was that? Yeah, when we multiply, this is half times cos 2 theta. So the integral of cos 2 theta is sine 2 theta over 2, and then we multiply it by half. That's why we have sine 2 theta divided by 4. And then here, okay, now it's over 2 because sine 2 theta is 2 sine theta cos theta. So the 2 here cancels with the 4 there, and we're left with 2 in the denominator. Okay, so now that we have that, then we can okay, we also need to substitute theta over here, even though I left it till the end. So if we have sine theta is equal to x over a, that means that theta is equal to sine inverse of x over a. So our integral is going to be a squared over 2. And then instead of theta, we have sine inverse of x over a. And over here, in the numerator we have x over 2 square root of this. I feel like I missed something here. I'm multiplying this out. Okay, we have x over 2 and then the square root of this. Okay, I think it's fine. Then we have x over 2 and the square root of a squared minus x squared plus the constant of integration. So as long as you get your substitution correct, that you let x equal to a sine theta, after you substitute, it's just basic algebra, and then you need to remember that at the end, you need to replace theta with, or rewrite theta in terms of x. So we look at some of the examples. Okay, so maybe I should just take note here. I should note that the integral of the square root of a squared minus x squared dx, this is a squared over 2 sine inverse of x over a plus x a squared minus x squared over 2 plus c. So that is the general formula. If you know what a is, you just substitute it over there. But I think in the test we will want you to work it out. So if this question is worth like 8 marks, you just substituting the values of a there will not suffice. I want to see how you are substituting and getting this over here. So now we have some examples. We have the integral of the square root of 1 minus x squared dx. So we will have to make a substitution. So we let x equal to a. Our a over here is 1. So it's 1 sine theta, which is just sine theta. Then we differentiate. We have dx is equal to cos theta d theta. From there, we make our substitution. For x squared, we will put sine squared theta. For dx, we put cos theta d theta, and then simplify, integrate, and then substitute. So this is the integral of the square root of 1 minus x squared, which is 1 minus sine squared theta. And then instead of dx, we put cos theta d theta. Okay, sine squared. Okay, 1 minus sine squared theta we know is cos squared theta. So I have the square root of cos squared theta, which is just cos theta. So cos theta times cos theta, this is the integral of cos squared theta d theta. Then again from here we rewrite it in terms of its double angle identity. This is the integral of half 1 plus cos 2 theta d theta, which is a half theta plus the integral of sine theta of cos theta. Cos 2 theta is sine 2 theta divided by 2, and then you multiply it by half. So you'll have a sine 2 theta over 4, and then add your constant of integration. Then now this is in terms of theta. We want to rewrite it so that it is in terms of x. So we would make use of our triangle. So we have a right angle triangle. We put theta over there. We say that x is equal to sine theta, so that means x over 1. So the opposite is x, the hypotenuse is 1, and this is 1 minus x squared. Then we know that sine 2 theta is 2 sine theta cos theta. So this is just a sine theta cos theta divided by 2, because the 2 here will cancel with that 4 over there. Then we can substitute. This is a half theta. We say that x is equal to sine theta. So theta is equal to sine inverse of x. Just take note. So x is equal to sine theta. So this means that theta is sine inverse of x. So those are what we're going to use to rewrite everything in terms of x. So this is half sine inverse of x. And then we said sine 2 theta is sine theta cos theta, and then here we divide by 2. So sine theta is x. So I have x, and then cos theta. Cos theta is the adjacent divided by the hypotenuse, square root of 1 minus x squared, and then this is all divided by 2. Then we add our constant of integration. Number 2, we have the square root of 16 minus x squared dx. So again, we have something squared minus x squared. Proceed in the same way. Make a substitution in terms of sign. So here our a is equal to 4, because I can rewrite this as the integral of 4 squared minus x squared dx. So my x will be 4 sine theta, and then dx is 4 cos theta d theta. Then just substituting, this is the integral of square root of 4 squared. Then I can just say 1 minus sine squared theta, and then d theta is 4 cos theta d theta. Okay, the square root of 4 squared is just 4. It'll come out and multiply with that one. So I will have 16, and here 1 minus sine squared theta is cos squared theta. The square root of that is cos theta. So I have 4 cos theta times 4 cos theta, which is 16 cos squared theta. So this is 16 cos squared theta d theta. And then again, making use of our double angle identities, I have 16 outside, then I have to put a half here, 1 plus cos 2 theta. One plus cos 2 theta is cos 2 theta, and then d theta over there. Okay, so the half can also come outside and multiply with the 16, so I will have 8. So this is 8, the integral of 1 plus cos 2 theta d theta, which is 8 theta plus 8 times cos theta times the integral of cos 2 theta. So I will have 8 sine 2 theta divided by 2, which is just 4 sine 2 theta. Okay, and then my constant of integration, of course. Then you have to remember the substitution that I made. Of x over 4, and then we need our triangle to work out sine 2 theta. So that's 2 sine theta cos theta, or 8 times sine theta cos theta. So our triangle, put theta somewhere here, and we said that sine theta is x over 4, so that's x over 4. This is root 4 squared x squared, or just 16 minus x squared. Okay, then we have everything we need in order to make the substitution. So it'll be 8 times sine inverse of x over 4, and then 4 times 2 sine of theta cos theta, or just 8 times sine theta cos theta. So this is 8 times theta. Theta, we said, is sine inverse of x over 4. Sine inverse of x over 4. And then this one we said is 8 times sine theta cos theta. So we have 8 sine theta is x over 4. And then cos theta from our triangle is the adjacent divided by the hypotenuse. So we have the square root of 16 minus x squared over the hypotenuse, which is 4. And then our constant of integration. Okay, just simplify, cancel whatever can cancel. So we have 8 sine inverse of x over 4. And here in the denominator we have 16, the numerator we have 8, so we'll be left with x over 2, then the square root of 16 minus x squared, and then your constant of integration. Okay, number 3, we have the square root of 4 minus 9 x squared dx. So again, we want to write it in the form a squared minus x. So there mustn't be any coefficients over here. So what we need to do is factor out the coefficient of x squared. So when we do that, we have the integral too longer. We're waiting for you. Thank you. Okay, so we say we need to factor out the coefficient of x squared. This is the square root. We take 9 out, and then here we will have 4 over 9 minus x squared, and then dx. So this 9 over here can obviously go outside of the square root, and when we have it in the form that we want, we have a 3 and the square root of 2 over 3 squared minus x squared dx. So now it is in the form a squared minus x squared, which we know how to integrate. So when it is in this form, we then make our substitution. So we say x is equal to 2 over 3 sine theta, and then that means that dx is equal to 2 over 3 cos theta d theta. Okay, then substitute everything there. The 3 must remain outside, and then I have the integral under my square root. The 2 over 3 squared, or the 4 over 9, is a common factor, and then I will have 1 minus sine squared theta, and then dx is 2 over 3 cos theta d theta. So here square root of 4 over 9 is 2 over 3. The 2 over 3 will multiply with that 2 over 3. I'll end up with 4 over 9. And 1 minus sine squared theta is cos squared theta. The square root of that is just cos theta. So I have cos theta times cos theta, which is cos squared theta. So what I'm actually integrating is the 3 outside, and then I have 4 over 9 and cos squared theta d theta. And just like we took the 3 outside, this 4 over 9 can go outside. So that outside we have 4 over 3, and then we're integrating cos squared theta. So this is 4 over 3, the integral of cos squared theta d theta. And we say to integrate cos squared theta, we rewrite that in terms of its double angle. So this is 4 over 3, and then a half, 1 plus cos 2 theta d theta. And again, the half and the 4 over 3 can multiply. So I have 2 over 3, integral of 1 plus cos 2 theta d theta. This very easy to integrate. This is 2 over 3 times theta plus 2 over 3. The integral of cos theta, cos 2 theta is sine 2 theta divided by 2. So the 2 here and the 2 that comes from the integral will cancel. So I will just have sine 2 theta over 3. And then you add your constant of integration. Okay, then again, remember theta was a substitution we made. It wasn't there in the original equation. So we now need to rewrite everything in terms of x. So the substitution we made was that x is equal to 2 over 3 sine theta. So this would mean that theta is equal to sine inverse of 3x over 2, and then our triangle, if we put theta over here, so sine theta is 3x over 2 or x over 2 over 3. Either one is fine. So we have 3x here. That's our opposite. And the adjacent is 2. Then we can work this one out as 4 minus 9 x squared. Okay, then we just substitute thetas over there. So this is 2 over 3. And theta, we said, is sine inverse of 3x over 2. And then we have the 1 over 3 here. Then sine 2 theta is 2 times sine theta, which is 3x over 2. And then cos theta is the adjacent over the hypotenuse. So the square root of 4 minus 9x squared divided by the hypotenuse, which is 2. Then any terms that can cancel, go ahead and cancel them. See, the 3's cancel, those 2's cancel. So I'm left with 2 over 3 sine inverse of 3x over 2 plus x over 2, and then the square root of 4 minus x squared. This is 2 over 3 sine inverse of 3x over 2, and then I have x over 2 square root of 4 minus 9 x squared, and then you add your constant of integration. Okay, so even here I should put my constant of integration like that. So these ones are pretty straightforward because you can see this is my a squared, this is my x squared, or like with the third one over here, you had to do a little bit of algebra to rewrite it like that, but that wasn't too difficult. But sometimes you get one that looks like this, the integral of the square root of 3 minus 2x minus x squared dx. So what we want to do again is to rewrite this in the form of a squared minus x squared, and to do that we need to complete the square. So remember how we complete the square, and when you do that you will end up with 4 minus x plus 1 squared under the square root dx. Okay, this x plus 1. So this is 4 minus x plus 1, the whole thing squared. Okay, so now it's in that form, kind of. So we can also make another substitution. We can say let u equal to this. So if u is equal to x plus 1, this means that du is equal to dx. So just for us to see it in that form, this is 4 minus u squared du. And we know how to deal with this one. The way we do it, make our substitution. So we let, not x this time, but we let u equal to a. Our a here is the square root of 4, which is 2. So this is 2 sine theta. And then this means that du is 2 cos theta d theta. And then substitute it over here, and then integrate as we have always been doing. So this is the integral of the square root. 4 obviously be a common factor, and then I have somebody saying something.
Can you hear me?
Go ahead, but you're very soft.
I don't understand what you did in the beginning. Please explain
What do you
that
mean?
again.
What do you mean what I did in the beginning here?
Yes.
I completed the square.
Oh.
Yeah. So from here, we'll have 1 minus sine squared theta. And then on the outside, I have 2 cos theta d theta. Okay, so as always, we'll have the square root of 4 times that one, so it's 4. And then this is cos squared theta. The square root of that is cos theta. So what I'm actually integrating is 4 cos squared theta d theta. And then we can integrate. We know that this cos squared theta, when we want to integrate it, we need to rewrite it in terms of its double angle. So I'll have half 1 plus cos 2 theta, and then the half will multiply by 4, and then I will have 2 on the outside. Okay, so here we have 4 times a half 1 plus cos 2 theta d theta, and this is 2 on the outside, 1 plus cos 2 theta d theta. So we now just integrate. This is 2 theta plus the integral of cos 2 theta is sine 2 theta divided by 2. So here when we integrate, we'll be dividing by 2, but then it also has to multiply by this 2. So then we will just be left with sine 2 theta, and then our constant of integration. So this is the integral, but our integral is in terms of theta, so we need to rewrite it so that it is in terms of x. So the first substitution we made was to write u in terms, so we can change from theta to u and then from u to x, or if you're able to do it directly from theta to x, by all means, go ahead and do that. So we say that u is equal to 2 sine theta. So we need to know what theta is. Theta is sine inverse of u over 2. And then we know that u is the substance. U is x, what is that? It's x plus 1. So you can say theta is sine inverse of x plus 1 over 2. Okay, and then sine 2 theta is just 2 sine theta cos theta. So we draw our right angle triangle. So we have theta over there, and if u is equal to 2 sine theta, then it means that sine theta is u over 2. So this is u, this is 2, and this is 2, opposite over the hypotenuse, and this is 4 minus u squared. Okay, and from here we can rewrite this in terms of x. This is x plus 1, and this is the square root of 4 minus x plus 1 squared. And this 4 minus x plus 1 squared, you can also just write it as 3 minus 2x minus x squared, because when you expand the brackets here, you end up with what you started with. Okay, so now substituting and rewriting everything in terms of x, we have 2 times theta, so it's 2 times sine inverse of x plus 1 over 2. So this is 2 sine inverse of x plus 1 over 2, and then 2, because sine 2 theta is 2 sine theta cos theta, so 2 times sine theta. Sine theta is u over 2, or x plus 1 over 2. And then cos theta is the adjacent divided by the hypotenuse. So we have the square root of 4 minus x plus 1 squared divided by the hypotenuse, which is 2. And then any terms that can cancel, you go ahead and cancel. So that 2 and that 1 will cancel. And then writing it nicely, we have 2 sine inverse of x plus 1 over 2 plus x plus 1 over 2. Then here we have the square root, so I can even rewrite it like this, which is 3 minus 2x minus x squared. Or write it like this one here, because they're exactly the same, except this you have completed the square and this is the one from the question. But either way, they are both exactly the same. So we look at some of the questions from exercise. This is page 25. So we look at some of the questions from exercise 4.6.1.2.3 relating to what it is we have done. So exercise 4.6.1/.2/.3, and look at question number 3. So here again, just to emphasize that there is a formula that you can use, or you can remember it if you're able to. Where did I write it? This is the formula for the integral, where you would just substitute a and then you are done with your integral. But with a question, you have to look at how many marks it is. So if a question like this is worth 3 marks, then maybe just go ahead and use the formula if you can remember it. But if it's worth 8 marks, you just using substitution to get the answer will not suffice. You must show all the steps. Okay, so number 3 from the exercise, we have the integral of the square root of 9 minus x squared dx. So again here, just make the substitution in terms of sign. So we will have ax is equal to a. Here our a is 3, so we have 3 sine theta, and then our dx, this is going to be equal to 3 cos theta d theta. Then we substitute in there. So what we are integrating is the integral, the square root of 9 will be outside. We will factorize it, and then we'll have 1 minus sine squared theta. And then outside the square root, we multiply by dx, which is 3 cos theta d theta. So this will be 9 cos squared theta d theta. Then the 9 can go outside, and cos squared theta, we rewrite it in terms of its double angle identity. So this is 9, the integral of a half, 1 plus cos 2 theta d theta, and the half can also go outside, so we have 9 over 2, 1 plus cos 2 theta d theta. So this is 9 over 2 times theta, and here the integral of cos 2 theta is sine 2 theta divided by 2. Then you multiply by this 9 over 2, so you'll have 9 over 4 sine 2 theta plus your constant of integration. Then our substitutions, so that we rewrite it in terms of x. So here we say that x is 3 sine theta, so it means that theta is sine inverse of x over 3. So theta is a sine inverse of x over 3. And then our triangle, because we need cos theta. So sine theta is x over 3, so that's opposite over the hypotenuse. And then here we have 9 minus x squared. Okay, we have everything we need to substitute there. So we have 9 over 2 times sine inverse of x over 3, 9 over 4 times 2 sine theta cos theta, and then add your constant of integration. So this is 9 over 2 times theta, we said is sine inverse of x over 3. And then we have 9 over 4 times, just put a dot, times 2 times sine theta. Sine theta is x over 3. And then cos theta, we say is square root of 9 minus x squared divided by 3. 9 minus x squared divided by 3. So any terms that can cancel, you go ahead and cancel them. And then, yeah, constant of integration. And then you simplify as far as possible. Here I'm having x over 2, so the 9 will cancel with these, and then the 2 will cancel, and then I have a 2 there. So this is 9 over 2 sine inverse of x over 3, and then I have x over 2 square root of 9 minus x squared plus my constant of integration. Let's see, 9. Okay, when you look at number 9, the integral of the square root of 10 minus 4x squared dx. So first thing we want to have our a squared minus x squared. So we don't want any coefficients of x squared here. So that's the first thing we must factor out. So we factor out the 4. So we have the integral of the square root 4. Then 10 over 4 is 5 over 2. Yeah, it's 5 over 2. Minus x squared dx. Then this square root of 4 is 2, which can go outside. So this is the integral 2, the square root of 5 over 2 minus x squared dx. Okay, then from there, we just need to make our substitution. So we let x equal to the square root of 5 over 2 sine theta. And this means that dx is equal to the square root of 5 over 2 cos theta d theta. Substitute over here. On the outside, we have a 2. Then the integral, you can see that 5 over 2 will be common. So we'll have the square root 5 over 2, 1 minus sine squared theta, and then multiply by dx, which is the square root of 5 over 2 cos theta d theta. Then square root of 5 over 2 times square root 5 over 2, this is just 5 over 2. And 1 minus sine squared theta is cos squared theta. The square root of that is cos theta. So what we have is 2, the integral of 5 over 2, and then cos squared theta d theta. Okay, then the 5 over 2 can go outside, multiply with this 2 here, and we just have 5 outside. So this is 5, and then cos 2 theta is a half, 1 plus cos 2 theta d theta. Okay, then again, this half will go outside. On the outside, I have 5 over 2, and then I integrate this one. So this is a 5 over 2. Then the integral of 1 is theta. And then again, I have 5 over 2 times the integral of cos 2 theta, which is sine 2 theta divided by 2. So in the denominator, I will have a 4 because of this half over there. So I have 5 sine 2 theta over 4, then add my constant of integration. Then rewriting in terms of x, so we say that x is equal to the square root of 5 over 2 sine theta. This means that theta is sine inverse of x over the square root of 5 over 2. You can simplify that and rewrite it better. So theta is sine inverse of x over the square root of 5 over 2. And then our right angle triangle. So put theta over there. We say that theta, sine theta is x over that. So the opposite is here. And this is the square root of 5 over 2. 2. It's our hypotenuse. Square root of 5 over 2. And then the adjacent, this is the square root of 5 over 2 minus x squared. Okay, now we're ready to put everything back. So here, 5 over 2. And we have a sine inverse of x over square root of 5 over 2, which is just square root of 2 over 5 times x. So we have square root of 2 over 5 times x. So that's what we're taking, not sine, sine inverse. Like that. Then you can put brackets there so it looks nice. And then 5 over 4 sine 2 theta is 2 times sine theta, which is x divided by the square root of 5 over 2, which is square root of 2 over 5x. And then multiply that by cos theta. Cos theta is the adjacent over the hypotenuse. So adjacent, the square root of 5 over 2 minus x squared, and then divided by the hypotenuse, which is the square root of 5 over 2, and then we add our constant of integration. Then we just want to rewrite this so that it looks better. So let's see. So this 2 here and that 4 there can cancel to leave a 2 in the denominator. And then here, dividing by the square root of 5 over 2 is the same as multiplying by square root of 2 over 5. So this square root of 2 over 5 and that one there will leave us 2 over 5. So I have 2 over 5 times let's see if this is correct. 5 over 2. Okay, yeah, so this will just be 5. When I multiply this one or this divided by that, it is just 5 over 2. So I have, no, it's 2 over 5. What am I saying? It's 2 over 5. Then 2 over 5 times 5 over 2 is 1. So what I have...
But won't the answer be 4 over 10? Square root 4 over 10.
No, what I have is this. The numbers that I'm multiplying, there's this 5 over 2 from this one, and then multiplied by that one, square root of 2 over 5, then multiplied by, see, this one is in the denominator, so I can write its reciprocal, which is just 2 over 5. And these two are the same, so the square root can go. So what I have is 5 over 2 times 2 over 5, which is equal to 1. Okay, so just be careful with the algebra. Okay, so this is 5 over 2, or do it on your calculator, it's easier. So this is sine inverse of square root 2 over 5 times x. And then I have x times the square root. Okay, just want to move this constant here. So there is a constant there. And what do we have? 5 over 2 minus x squared, then plus the constant of integration. Okay, so it seems the trickiest part is just putting back everything in terms of x and simplifying. So just be careful with that. Or like I said, do it on the calculator. It's much easier, saves a lot of mistakes. Okay, so number 14 and 15, those ones involve completing the square. You can try those. And we will continue tomorrow with another trigonometric substitution.
Miss,
Yeah.
Miss,
Yeah.
I just wanna know